Let's talk about complex rational expressions. So complex rational expressions essentially have fractions with other fractions on the numerator and or denominator. So there are a couple different ways that you can approach simplifying these. The goal is to get a single fraction that just has a numerator and denominator that are polynomials in standard or factored form. They don't have any fractions within the numerator or denominator. So one method is to separately simplify the numerator and denominator until each one of those is a simple rational expression, and then do the rational division process. Another method is to multiply each term on the numerator and each term on the denominator by the denominators that occur within the smaller fractions, either all at once or one at a time until they've all canceled out. And at that point, then there may be some additional simplifying, but there shouldn't be fractions within the fraction. So we're going to look at some examples using each of those processes. So the first example, we have 1/2 plus 3 over x plus 3 over 4. So using the first method, I'm going to just work on simplifying the top and the bottom separately, and then eventually be able to do the division. So adding the 1/2 plus 3 over x, I'm going to take 1/2 times x over x plus 3 over x times 2 over 2. So that'll get me the common denominator there. The bottom is already one fraction, so I don't need to do anything else with that. So I'm just carrying that along. So this is x over 2x plus 6 over 2x, still over the x plus 3 over 4, and then that becomes x plus 6 over 2x being divided by x plus 3 over 4. And now I'm going to go ahead and apply the division is multiplying by the reciprocal. So this is x plus 6 over 2x times 4 over x plus 3. So I do that flip. The 4 and the 2 cancel. So this is 2. And so I end up with 2 times x plus 6 over x times x plus 3. All right. Then method 2, I'm going to take, so I have the 1/2 plus 3 over x plus 3 over 4. And I could do this one at a time. So I have the 2 and the x and the 4. I could do it one at a time, or I could do it all at once. Let's see. I'm going to go ahead and multiply everything by the x first. This is there's also different ways this could be done. All right, so the x distributes on the top there, so we have x times 1/2, which is x over 2. And then we have 3 over x times x, and there the x's cancel, so I just have 3. And then on the bottom, I'm just going to have x times x plus 3 over 4. And then I'm going to go ahead and multiply everything by 4. And I skip the 2 because that's going to be covered by the 4. So again, this distributes. And so I have x over 2 times 4. And that becomes 2x. And then 3 times 4 is 12. And then on the bottom, the 4 cancels. And I just have x times x plus 3. And we now have that simple fraction. I could factor out or leave it this way. So the 2x plus 12, notice that's the same as 2 times x plus 6. Either way should be fine. Depending how many steps you break it down, if you do, you could do the 2 and then the x, and then you have to do another 2, or you could do the 4x all at once. But with this example, method 2, even with breaking it down into a couple of steps, seemed simpler, although I didn't write out some of those in between steps. So it's kind of a matter of preference. But looking at this next one, so again, I'll start with method 1, where I simplify the top and bottom separately. So on the top, I have the x squared over x minus 4, and then I need the 2. So I need the x minus 4 common denominator. I need to multiply it by x minus 4 over x minus 4 so that I can correctly combine it. And then on the bottom, similarly, 2x minus 2 over x, and then it's going to be minus x over x. So now I have common denominators. I can go ahead and combine. So I'm going to have x squared plus 2 times x minus 4 over x minus 4 on top. And then on the bottom, and I could do more of this all in one step, but I'm just writing, so 2x minus 2 minus x over x. So I could have gone straight to this and have x squared plus 2x minus 8 over x minus 4, and then x minus 2 over x. Whether you need to write that intermediate step or not is completely kind of a matter of what you're comfortable with and what your preference is. But at this point, I can do the division and do the flip. So this is x squared plus 2x minus 8 over x minus 4 times x over x minus 2. But somewhere here I need to factor the x squared plus 2x minus 8. So that's going to be x plus 4 times x minus 2. And so the x minus 2 cancels. And we end up with just x times x plus 4 over x minus 4. So that took a little more. Again, I could have written out some less steps. I could have also combined different things, but so the question is, would method 2 make this any easier? Or is it harder, or are they the same? But just to see another way to approach this. So here, the denominators I have to deal with are the x minus 4 and the x. So I'm going to go ahead and multiply. So I'm multiplying the top by both of those and the bottom by both of those. And then they get distributed to each term on the top and the bottom. So I'm going to try to consolidate this a little bit just because I don't have room to write them all out separately. So multiplying by the x squared over x minus 4, the x minus 4 cancels, and I'm left with x squared times x. So again, so this is something like this. Those cancel, right? The 2, there's nothing to cancel. So I have 2 times x minus 4 times x. All right, but we're already getting somewhat simpler in that I've gotten rid of the denominator. Then the 2x minus 2 over x multiplied by the x minus 4 and the x's cancel. So I have 2x minus 2 times the x minus 4. And then the minus 1, again, just gets both of those. So now I have a lot more so expanding on the other method. I just had one distributing that had to be done, and then some factoring. Here I have kind of a bunch of like foiling, distributing, and stuff to do. Although I could shortcut this. So one way, rather than distributing, if I note that these each have an x in them, then I can factor that out, and it's x times x squared plus 2 times x minus 4. And then on the bottom, they both have an x minus 4. So that's really just needs to be x minus 4 times 2x minus 2 minus x. And then we get more kind of to this. I think that's, yeah, kind of to this step. So we have then x times x squared plus 2x minus 8 over x minus 4 times x minus 2, and then factoring. So it's like the multiplication has already been done. And then I still need to do the factoring and cancel. And get there. But if you don't recognize that, which you may not, and then you would distribute, do all the multiplication, you'd have x cubed plus, let's see, 2x, even if I write this 2x times x minus 4, then that would be 2x squared minus 4x. And on the bottom, you would have like 2x squared minus 8x minus 2x plus 8 minus, let's see if I make this minus x times x minus 4 minus x squared plus 4x. And then we would have on the bottom there would be x squared minus 6x plus 8. And then we have to factor back out again. So this would be x times x squared plus 2x minus 4. Sorry. Sorry, that was a minus 8x there. Minus 8. So then we get x times x plus 4 times x minus 2 and x minus 2 times x minus 4, and we get that. But there was extra steps and they're kind of a multiplying and then a factoring back that didn't really need to happen. So in this case, method 1, I managed to squeeze method 2 in a smaller space there, but I think really method 1 was simpler on this example. But either way will work as long as you stick to the correct rules of how fractions and multiplication and factoring and all of that stuff works. You can really use either of those methods. So that's complex rational expressions.